Hi and welcome to another tutorial video. In this tutorial video I'm going to be comparing the adjacency list and adjacency matrix and just showing you which one is appropriate to use in different situations. So we've got two ways of representing a graph in software. We've got this adjacency list and the adjacency matrix. And when we're thinking about what way to represent our graph in a program, the key things to think about are how much memory or storage space the implementation is going to take up when our program is run, and also how much time it's going to take to access and that data and produce for the program to produce a useful result with that data. So for example, what I mean by that is how much time it might take to work out whether there is a connection between two nodes, for example. Okay, so let's get into this then. What are the advantages of using an adjacency list? So the advantages of using an adjacency list. Well, the big advantage of using an adjacency list is that it is the most space efficient solution. So the solution that's going to use the least amount of storage space if we're representing a graph which is sparse. So it's the most space efficient solution for sparse graphs. And what do I mean by a sparse graph? So a sparse graph is one which doesn't have many arcs connecting the nodes. So an example of a sparse graph, relatively sparse graph, might be something like this. We've only got 3 arcs between our nodes, and a sparse graph is one, generally speaking, is one where there's a relatively small number of arcs connecting the nodes compared to the number of nodes. So this graph would likely to be considered to be sparse because it's got relatively few arcs. If we added in some more arcs, for example, then we could say that the graph is much more dense. So what we're saying here is that the adjacency list is a more space efficient solution for sparse graphs. So why is that? Well, with an adjacency matrix, you're storing some data regardless of whether there is a connection between two nodes. You're storing a 0 or an infinity sign if there isn't a connection between two nodes. Whereas with an adjacency list, what we're doing is we're only storing data when there's a connection between nodes. So for a sparse graph where there's not very many arcs connecting the nodes, it makes sense to use an adjacency list because we want to avoid having the situation with the adjacency matrix where most of the adjacency matrix is just a 0 or an infinity sign because there isn't a connection between nodes. Okay, so this is the primary reason that you would choose an adjacency list. But what about the adjacency matrix? What does the adjacency matrix have going for it? With an adjacency matrix, the issue is that depending on what kind of graph we've got, we could be wasting a lot of storage. But the advantage, the key advantage, is that adding an edge or testing for the presence of an edge is much quicker to do than with an adjacency list. Also, if the graph is dense, using an adjacency matrix might be more suitable. You might choose to use an adjacency matrix because the space saving benefit of an adjacency list is going to be negligible because most of your nodes have connections between them. And obviously you've got the speed benefit that I've just outlined here with operations like adding an arc or testing for the presence of an arc is much faster. So you've got that to consider as well. So generally speaking, if your graph is sparse, so there aren't many arcs connecting the edges, then you want to go for an adjacency list. Whereas if your graph is very dense, then the better option is probably going to be the adjacency matrix. Okay, so that brings me to the end of this tutorial video. I hope you found it useful, and thanks for watching.